Today we're going to talk about how to use the distributive property to factor polynomials. Let's look at the steps to do this. Step number 1 is to factor each term of the polynomial. Step number 2 is to circle the factors they share. Hey, this sounds a lot like greatest common factor, which we've been doing. Step number 3 is to rewrite each term using the greatest common factor as the coefficient. And step 4 is to rewrite using the distributive property. Well, let's go ahead and take a look at an example or two. Here's our first example. We have 27y squared plus 18y. Well, let's go ahead and prime factor both of these completely. For 27y squared, we have 3 times 3 times 3 times y times y. For 18y, we're going to have 2 times 3 times 3 times y. Our next step is to go ahead and look at the factors that they share. When I look at this, I see that they share a 3 here, a 3 here, and a y. Well, I'm going to go ahead and pull those out and multiply it back together, and I'm going to have 9y. So the greatest common factor is 9y. Our next step is to rewrite each term, but to use 9y as the coefficient. So let's take a look at that. We're going to do 9y times 3y. Where did I get the 3y? That's what's left after we pull out the greatest common factor. After we factor out 9y, what's left in the first term is 3y. Since it was an addition, I'm going to add it to 9y times 2. Where did I get the 2? Well, it was what was left over from 18y after we factor out the greatest common factor. The distributive property says I can rewrite that as 9y times the sum of 3y and 2. Let's take a look at another example. Here we have subtraction, but it's going to work the same way. We have 15w minus 3v. First step is to go ahead and prime factor those. So 15w is 3 times 5 times w, and then 3v is just 3 times v. If I circle the factors that they share, the only factor that they share here is the 3 times 3, or the 3. So I can go ahead and pull that 3 out. So our greatest common factor happens to be 3. So I'm going to rewrite each term after I've pulled out the greatest common factor. So 15w becomes 3 times 5w. And then from that, I'm going to subtract 3 times what's left over is v. So I have 3 times 5w minus 3 times v. I'm going to use the distributive property, which says I can rewrite that as 3 times the difference of 5w and v. Let's take a look at one more example before we move on. And in this one, we have a trinomial. It's going to work the exact same way. So let's take a look. We're going to start out by prime factoring each one. So after we get them factored, we're going to look and see what they share. Well, this one has a 7, that one has a 7, but this does not. We've got a 3 here, but that's the only 3 I see. So it looks like we can pair up a u, okay? And it also looks like we can pair up a t. So those are the only two factors that they share. If I multiply those back together, I've got ut. Now I'm going to rewrite each one, and I'm going to use ut as the coefficient. So for 7u squared t squared, I'm going to rewrite that as ut times 7ut. And then for 21u t to the second power, after I pull out ut, all that's left is 21t. So I have ut times 21t. And then from that, I'm going to subtract whatever's left after I pull out the ut here. Well, you might think that there's nothing left, but remember, 1 is always a factor. The ghost of 1 is always there. So we're going to rewrite that as ut times 1. Distributive property says I can use ut and I can say UT times 7UT plus 21T minus 1. Well, I hope this helps you, and as always, if you have any questions, be sure to reach out to either one of us.